One of the most fascinating astronomical events is the potential supernova of Betelgeuse, located in the famous shoulder of the constellation Orion. Betelgeuse is a red supergiant star, nearing the end of its cycle. Surprisingly, in 2019, one of the brightest stars in the sky began to fade noticeably, being visible even to the naked eye. But for several months, its brightness decreased so much that many observers wondered if the star was dying. Turning their telescopes towards the giant star, scientists were astonished by the evidence of the great dimming. Betelgeuse is believed to be close to exploding into a supernova, marking the end of its life cycle. But when and why will this stellar explosion occur? Could it have devastating consequences for Earth? The glowing ruby star, Betelgeuse, lies on the upper right shoulder of Orion, the Haunter. You may recognize it by its other name, Alpha Orionis. Although it is the second brightest star in its constellation, behind the supergiant Rigel, it remains one of the most interesting to astronomers because of its variable behavior and peculiar name. Alpha stars are usually the brightest stars in the constellations, and although Rigel outshines it in brightness, Betelgeuse stands out for its size and reddish color. Betelgeuse, also known as Alpha Orionis, is one of the most famous stars in the night sky, being the 10th brightest and 7th brightest visible from much of North America, Europe, and Canada. Its name comes from Arabic and means armpit of the giant, in reference to its position in the constellation. Betelgeuse loses about 1 unit solar mass every 10,000 years, ejecting materials evenly in all directions, forming a nebula around it. This nebula has a diameter of 30 astronomical units, which is 30 times the distance between the Earth and the Sun, and is 250 times larger than that star itself. At its core, Betelgeuse's hydrogen atoms fuse under the immense gravity, producing helium, releasing light and heat in the process. As the star exhausts its hydrogen, it begins to fuse helium and carbon as fuel. When the helium is consumed, neon reacts with carbon, forming iron. The fusion of the iron releases no energy, causing the star to collapse under its own gravity and eventually explode in a supernova, one of the most powerful explosions in the universe. Depending on their age and evolutionary stage, stars emit light in different wavelengths, from the bright blue of young stars to the red of older ones. According to the ancient astronomer Ptolemy, Betelgeuse had a color that he curiously described as rough. However, ancient Chinese astronomers noted that Betelgeuse appeared to have a yellow color, suggesting that in the past it may have been a yellow supergiant. Large stars tend to consume their hydrogen rapidly, bringing them to a premature end, even if their lifetime is only 10 million years. There is no doubt that Betelgeuse is in the last stages of its existence. While our Sun still has more than 5 billion years to go, Betelgeuse is nearing the end of its life, which means that at some point it could explode as a supernova. However, the exact timing of this event remains uncertain. Betelgeuse goes through 2 brightening and dimming cycles, one of which occurs every 5 years and lasts about 100 days. It is believed that the expansion and contraction of this outer shell during these cycles causes changes in its diameter and average temperature. Many paid attention to Betelgeuse because of its erratic behavior in 2019 and 2020, when its brightness decreased dramatically, only to recover temporarily. Some astronomers have had speculated that this behavior could indicate that the star is in its final stages of its life. Detailed studies of Betelgeuse date back to the 1st century BC, but the cause of its sudden dimming remains a total mystery. Betelgeuse has been detected moving through the interstellar medium at a speed of 30 kilometers per second after being ejected from its place of origin in the Orion OB1 association, which contains the stars of Orion's belt. Its shock arc extends more than 4 light years. Determining the distance to red supergiant stars like Betelgeuse is a notoriously complicated task in astronomy, as multiple factors make it difficult to calculate its exact diameter. In addition, as a pulsating star, Betelgeuse's size changes with time. This phenomenon, together with the dimming of the stellar limb, causes its visual emission to change color and dim as we move away from the star's center. In addition, the circumstellar envelope, composed of the material ejected by the star, plays an important role in emitting and absorbing light, which also influences how we perceive its brightness. Direct comparisons between observations of Betelgeuse are difficult to make, as its apparent size varies depending on the wavelength used. Diameters can fluctuate by as much as 35% depending on the wavelength used to measure them within the electromagnetic spectrum. In July 2009, the European Saturn Observatory published images captured with the VLDI interferometer on its ground-based telescope, showing a huge plume of gas extending up to 30 astronomical units from the star's atmosphere, one of multiple mass ejections recorded from Betelgeuse. This ejection was comparable in size to the angular separation between the Sun and Neptune. At least 6 ejections have been discovered around Betelgeuse. This phenomenon may offer clues to the mystery of mass loss in the final phases of these giant stars, which could be the key to their demise. The complex dynamics of Betelgeuse's extended atmosphere remain an enigma, as does the exact mechanism by which these red supergiants eject material. These stars are essential to the cycling of matter in galaxies, and thanks to advances in interferometric techniques, astronomers are closer to solving this enigma. In 2019, researchers using Hubble telescope and other telescopes discovered that Betelgeuse had ejected a large portion of its vital visual surface, generating a significant surface mass ejection. Although the Sun produces coronal mass ejections, the events at Betelgeuse were thousands of times more intense, with its SME ejecting an amount of material 400 billion times larger than a typical solar coronal ejection. This explains why Betelgeuse experienced a rapid decline in brightness in October 2019. By mid-February 2020, it had lost about 3 times its luminosity, going from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had remained relatively stable for more than a week. On the 5th, it appeared that the star had stopped dimming completely. However, the recent visual fades were not related to a possible collapse of its core, as no significant infrared changes were observed on February 24, 2020. Let me know what you think in the comments box. If you liked the video, hit the like button and subscribe so you don't miss out on more content like this one.